morning. In this session, we evaluate the allotropes of carbon. Allotropes is defined simply as different structures of the same element. Carbon as an element has a varied range of allotropes, including diamond, graphite, Buckminster fullerenes, which is an artificial form of allotrope, coke, charcoal, and amorphous varieties. In this session, we are going to give a critical analysis of the two main allotropes of carbon, namely diamond and graphite. To begin with, diamond is an allotrope of carbon which is tetrahedral in shape. The tetrahedral nature of the structure is as a result of the network of synthesis of carbon atoms. We find that in diamond, one carbon is always attached to 4 other carbon atoms, and that network continues in a sequence of multiple series. Now, the bonds in between carbon and carbon are strong covalent bonds, making the structure rigid and having high melting and boiling points. Now, to enable us critically review what importances diamond has, we look at its physical properties alongside its common applications. To begin with, diamond is a rigid structure made up of strong covalent bonds. It is tetrahedral and crystalline. It is of strong covalent bonding. It has high melting and boiling points. And to effectively utilize it, we find that diamond has been discovered as the hardest known substance on Earth. Now, we use it in the manufacture of drill bits, which are the heads for cutting substances. We also use it to manufacture guillotines for glass, and we use it in jewelry because of its crystalline nature. The second common allotrope of carbon is graphite. Now, graphite is a soft substance and it is slippery in the sense that when you attempt to press on it, it will slide one layer over the other. Now, what are then the physical properties of graphite? As said, graphite is hexagonal biplanar in the sense that each carbon atom is attached to 3 other carbon atoms, and then a molecule is linked to another molecule by weak intermolecular forces of attraction referred to as the van der Waals. So, we say that graphite is soft and slippery. It is hexagonal biplanar in structural form. It has weak intermolecular forces of attraction, named here as the weak van der Waals. It has low melting and boiling points, and it's black in color. Now, the nature of the color enables us to use it as pencil tips. So we use it in the manufacture of pencil tips because it's black and because it cleaves one layer over the other. While the weak van der Waals forces are pressed on, the first molecule slides over the other, the process referred to as cleaving, and when it is a pencil tip, the cleaving action enables the black tip of the pencil to stick on a white surface while rubbing. Now, we use it as a lubricant because of its slippery feel, and it is used as an electrode simply because it has no delocalized electrons. Remember, carbon has the electron configuration 2:4, the valence is 4, and its network of bond formation is normally 4 carbons, each carbon carrying 4 bonds. Therefore, since graphite has each carbon joined to only 3 other carbons, there is always 1 delocalized electron per molecule. And these delocalized electrons are the ones which are effectively used in the transmission of electric charge. When you look at diamond, on the other hand, each carbon is joined to 4 other carbon atoms, which means all the bonds of carbon are utilized, all its electrons are intact, and therefore there are no delocalized electrons, and for that reason, diamond does not conduct electricity. We have also said that there is an artificial form of allotrope known as the Buckminster fullerenes, which is simply fabricated by glazing the surface of either diamond or graphite or any other allotrope of carbon with laser beams, and these laser beams will transmit and transform the diamond or the graphite into Buckminster fullerenes. Coke is another black form of allotrope of carbon, and charcoal is another one which is relatively weak, and there are many other varieties which are amorphous in shape. So that has been simply a description of the varied forms of carbon named as allotropes, diamond, and graphite, alongside other subsidiaries. In our next session, we are going to evaluate the oxides of carbon. Thank you.